Hey guys, my name's Sam and today we're going to take a look at how to choose the LiPo battery for your next project. So as technology continues to develop and more devices are becoming portable, we've got an increased reliance on batteries, and we've got these wonderful battery technology known as LiPo, which is short for lithium polymer batteries or lithium ion polymer batteries. We're going to stick with LiPo today. So there's a few different things we need to understand, and if you're not sure what LiPos are or how to integrate them with your projects, then we've got some separate tutorials on those for using LiPos in your projects and some chargers and products that are going to help you use those. But today we're going to take a look at some of the specifications and key points to look for when you're choosing a battery for your next project. So the first thing we want to be aware of is what a cell is. So LiPo batteries are made up of cells, and most batteries are going to be made up of a single cell. And a cell is a bit like a smaller battery, lower level battery inside of the battery casing that you have here. So as we said, most batteries are single cell batteries, and they are known as 3.7 volt nominal charge batteries. We'll get to voltage in a moment, but you can get batteries which have a higher voltage because they have multiple cells in there. So you might see packs that have 2S or 3S written on them, and that stands for 2 series or 3 series. The S stands for series, and it means there's multiple cells wired in series, which of course the voltages add together to give you a higher nominal voltage battery. So we're talking about voltage and we're saying nominal voltage. And that's because with voltages, you've got to be a bit careful with LiPo batteries. So we refer to a cell as 3.7 volts, but when you fully charge a LiPo, it's going to rest at about 4.2 volts maximum charge. And when it's fully discharged, it's going to be around 3 volts, and you should never exceed those limitations. Otherwise, you can cause damage to your LiPo, potentially cause it to overheat, swell, or catch fire. Got to be safe when you're using LiPos. So a good quality charger won't allow it to charge over 4.2 volts. And likewise, if you've got some sort of protection system in place, it can trigger when your cell voltage gets to the 3.2, 3.1 mark, and you know you really need to recharge your battery. So that's voltage. And of course, if you had a 3-cell battery, then the nominal voltage might be at 11.1 volts, and it's going to be higher when it's fully charged and lower when it's depleted. Then the biggest thing that's going to impact your project is the battery capacity, and this is directly related to size. The bigger the battery, the more charge it can hold. And capacity is measured in a unit known as milliamp hours. So you've heard of milliamps perhaps, or amps. Milliamps is a subunit of amps, which is the amount of energy flowing at a given point in time, and milliamp hours is the amount of charge that it can store before it is depleted. So what does milliamp hours mean? Well, take this guy. It's a 1000 milliamp hour LiPo battery. And that means that it can provide 1 amp or 1000 milliamps for 1 hour before it's depleted. It could provide 500 milliamps or half an amp for 2 hours before it's depleted, and so on and so forth. And it could provide, providing the battery is able to deliver that much current, which we'll get to in a second, it could provide 2 amps for half an hour. So you can apply that to all of the different battery capacities there. And I've put a formula in to calculate the time and the power that you can draw from the LiPo before it will be discharged down there. So take a look at that if you want to work out exactly how much life your battery is going to give your project once you know the average current draw of your project. Now, the discharge rating is particularly important both for safety and to preserve your LiPo. So the discharge rating obviously refers to the current that it can discharge at any given point in time. Now, there's a special rating known as a C rating, where C is multiplied by the capacity of the battery, and that gives you the maximum discharge. So a battery may have a rating of 1C, for example. So you would multiply 1 by your battery capacity, and that is the maximum amount of current that it can discharge. So again, a 1000 milliamp hour battery with a 1C rating could discharge 1 amp continuously. If it had a 2C rating, it would be 2 amps. This guy here, a beefy 6000 milliamp hour, if it had a 2C rating, would be 12 amps, 1C, 6 amps. and so on and so forth. It's fairly straightforward, and on top of that, some batteries will also give you a boost or a burst C rating where you can temporarily, for a short period of time, draw more current than the typical C rating, but for the most part you want to stick within that given C rating, otherwise you can cause your battery to swell up, damage to your projects as mentioned, and also bear in mind that the wires on some batteries may be thicker or thinner and are capable of carrying less current. So this 1000 milliamp hour battery might have thicker wires than a much smaller battery, which is going to limit the current. So on some battery pages it says restrict the discharge to 1 amp despite the C rating, unless you want to replace the wiring harness, which I only recommend doing if you really know what you're doing. So that's the charge rating and the discharge rating, I should say. The charge rating is the exact same thing, but how much energy it can be charged with at any given point in time. It's fairly common sense, although charging at 1 amp is pretty recommended. Now, size is directly related to capacity. The bigger the battery, the more energy it can hold, the more space it takes up. It's fairly common sense. And I've got a couple of different batteries here, which I recommend for all sorts of different projects, depending on how you're using them. You've got your really small 120 milliamp hour battery, your 1000 milliamp hour battery, so stepping up almost 10 times the capacity, but it's still nice and flat, which is good. Then in between, you've got a cylindrical battery, and this is known as an 18650 cell. They're designed to sort of look like big AA size batteries, but they're actually LiPo batteries and work in the exact same way, but are ideal if you need something that's a bit narrower, but you don't need that flat form factor. And then again, 6000 milliamp hours, this guy's really chunky, so 6 times the capacity of the 1000 milliamp hour here, but a bit thicker, and it does a really good job of powering your chunky projects if they need a lot of juice and give them a decent battery life, or just make that project that you've got go forever without needing to be recharged. So that's a bit of an overview about all the specifications of LiPo batteries that you need to be aware of, and hopefully now you can go on and know what project it is that you want to build and pick a battery that's going to best suit that project based on the voltage it needs, how long it's going to last, and the physical dimensions of the battery itself. If you've got any more questions, then let us know in the comments below. Get the conversation started, and we'll see you next time, guys.